Hello, today we are going to take a look at some one-sided limits. Now when you find a one-sided limit, it is a lot the same as finding a normal limit. It's just that when you're looking at a normal limit, it says, what value is the function approaching from both sides of the limit point? So in that graph I drew, as x approaches c, what y value is the function approaching? But limits, one-sided limits ask a little bit different question, and they become more interesting if the function is split. Because in this case, the limit does not exist because the function approaches two different y values. However, the one-sided limit does exist. The limit as x approaches c from the left, and when you see that little negative sign, it means from the left. So as I'm writing this function from the left, what c value do I approach? Call it a. However, I can change my notation a little bit and say limit as x approaches c from the right with a little plus sign. Now I'm writing the function coming from the right side, and it approaches a different y value, so it is b. So even though I'm looking at the limit at the same point, the same limit point of c, it approaches two different y values. And with the power of the one-sided limit, I can say something about that, despite the fact that the limit as x approaches c of f of x does not exist. But each one-sided limit does. The one-sided limit becomes pretty interesting when you investigate functions where the limit does not exist. Okay, and that happens a lot in vertical asymptote situations. So one-sided limits are used a lot in functions that have a vertical asymptote, such as this one, which is in fact the graph of 1 over x minus 8, which is the limit we're going to look at. And notice how if I say what's the limit as I approach 8 from the left, my graph is going towards negative infinity. So that answer is negative infinity. But as I approach the graph from the right, I'm shooting up towards positive infinity. So the limit as x approaches 8 from the right is positive infinity. Let's look at the actual question. The limit as x approaches 8 from the right of 1 over x minus 8 is equal to positive infinity, which is what we just said there. But I want to take a look at this as if I did not have this graph, okay? So imagine you didn't have the graph to look at, because it's pretty easy to find a one-sided limit with the graph. And you should be able to envision the graph in your head anyways, especially of a basic function kind of like this. But what you want to do is if I have the limit as x approaches 8 from the right, and I have 1 over x minus 8, I know there's a vertical asymptote there. I should know that, okay? When I see this function, I should know there's a vertical asymptote at 8. Okay, so I know my answer is either infinity or negative infinity. When a limit approaches an asymptote, it's either infinity or negative infinity. But which one? Okay, that's where you think about, if I'm approaching from the right, my values are bigger than 8. So maybe 1 over 9 minus 8, which could be a positive 1. Or I get closer, so it's 1 over 8.5 minus 8, which is 1 over a positive 0.5, which is 2. So my values get bigger as I get closer to 8, which just reinforces this idea that I'm going towards infinity. But you already know you're approaching infinity, so you don't need to do that whole limit process of getting closer and closer to 8 and try 8.01 and 8.001. It's just going to get bigger towards positive infinity. The question is it going towards positive or negative infinity? And you can see that as you put in a value greater than 8, because I'm coming from the right, the bottom here is positive, which means I'm a positive number divided by a positive number. It's a positive overall, a positive infinity. That is contrasted with if I say the limit as x approaches 8 from the left of our same function. Now I want to plug in a number that is smaller than 8. So I go 1 over 7 minus 8, which is 1 over negative 1. And you see I'm having a positive divided by negative, which gives me a negative infinity. And I can go and suppose that it's infinity because of my math knowledge, that at 8 there is a vertical asymptote. So the answer to my one-sided limit is either infinity or negative infinity. And I see that when I plug in a 7, it is negative. So that's a thing you can do without a graph. So I'm going to take a look at another problem now, and we'll try without graphing it at all, and see if we can find the one-sided limit. Alright, so here we are. Now with one-sided limits, you can always try direct substitution, and you should, because sometimes you get an answer from direct substitution. But you can see that once I plug it in, I get 10 divided by 0, which is saying I have an issue. But that doesn't mean there's no answer for my one-sided limit. And you can see here that I can do a little bit of simplifying, and maybe something will happen. The bottom is a difference of squares, so I have x plus 5, x minus 5. The x plus 5 cancels out, leaving me just 1 over x minus 5. Now when I plug in, I still get 0 in the denominator, so it's not like I resolved my issue. But when I look at this, I can much easierly recognize that I have a vertical asymptote at x equals 5. So I know my one-sided limit is either positive or negative infinity. Which one? Well, this is where you just take a number less than 5 and pick one pretty close to 5. So 1 over 4 minus 5, and that gives me 1 over negative 1. That is a negative value. So the answer to my limit is negative infinity. I know it's approaching a negative value. Now, it's important to think about this type of function and recognize what's happening at both 5 and negative 5. So at 5, there's a vertical asymptote because after canceling out, I'm still left with x minus 5. Okay, if I cancel out and there's still something in my denominator, that means that is a vertical asymptote. But what about that x plus 5 that canceled out? Well, that means that x equals negative 5 in the graph of it. Now what the graph looks like might be a little bit something like that. There's a hole at x equals negative 5. So if I wanted to find the limit as x approaches negative 5, I would get an answer. I could just plug that in. I would plug it into my simplified version of 1 over x minus 5, and I would get 1 over negative 5 minus 5, which equals 1 over negative 10. So even though the function is not defined at x equals negative 5, the limit is equal to negative 1/10, and the limit from the left, the limit from the right, and the limit all equal negative 1/10. I want to take a look at one final limit problem here. Now you can see that as I plug in 9 into this, because you do still want to try direct substitution with your limits. If I plug in 9, I get 3 minus 3 over 9 minus 9, which is 0 over 0. Problem, undefined. So you look at this and you're like, okay, what steps can I do to try and eliminate that problem? I even look at this and I'm not sure where the vertical asymptotes are. Okay, because I do not just have a 1 up top, I have a square root of x minus 3. And I know clearly where my asymptotes are when it's 1 divided by something. Okay, or if my denominator is factored as far as it can be and canceled at the top. So that's the better rule. You know where asymptotes are once you factor completely and everything is reduced and canceled out. That's your vertical asymptotes. And even though that might appear to be the case here, it's not. I can actually find a clever way to factor this to identify where my asymptotes are or / eliminate my problems with my limit. It's a clever bit of factoring. But this bottom, I can force it to be a difference of squares by saying it factors as square root of x plus 3, square root of x minus 3. Okay, that's because square root of x, if I square that, that's x. If I square 3, that's 9. Hey, so not often do I factor such that I get square roots. But in this case, I want to because I saw that square root of x minus 3 up top, and I was like, that would be cool if I could get that in my denominator. And so I did it. And then, once I cancel that, I get 1 over square root of x plus 3. And it is clear now that nothing more can be factored. And so now I can try my one-sided limit. And in fact, I don't even have to do the thing where I'm approaching 9 from the left, so I put in a 10. Because I want to go to direct substitution. And what do you know? It works. So my limit is 1 over 6, which is the same the limit as x approaches 9 from the right and the limit as x approaches 9. Okay, but it was that clever factoring technique that helped us out. Now very quickly, there is another way to do this, and this might be the more apparent one since you have worked with rationalizing denominators and using conjugates before. If I have this limit as x approaches 9 of square root of x minus 3 over x minus 9, and I multiply by the conjugate of the top, I'm essentially just doing that factoring pattern on the top now. So once I distribute this, a squared minus b squared, I get x minus 9 over square root of x plus 3 times x minus 9. Those cancel. 1 over square root of x plus 3, which is where I was at before. I evaluate the limit, and I get 1/6. 2 ways to crack the same egg and get the job done both ways. Okay, so that's our little talk on one-sided limits. I hope it's useful. The big idea there is you do not have to graph a one-sided limit to figure it out. Instead, you can plug in a number either on the left side of your limit point or on the right side and determine is it a negative value or a positive value, and that will tell you if it's approaching positive infinity or negative infinity, so long as you're at a vertical asymptote.